Okay, so Devasmita, yeah, we can go live. So we are going
Yeah,
live. Yeah,
yeah, we are live. Yeah. So, very good evening, everyone. A very warm welcome to the professors on board and our special guest, Dr. Akhilesh Gupta from DST. We are very happy to have you here with us today, sir. And it's my immense pleasure to welcome all the viewers to this eighth eSchool on Climate Science and Policy being organized by Interdisciplinary Program in Climate Studies at IIT Bombay and supported by DST, that is the Department of Science and Technology under Government of India. Due to the ongoing pandemic, what used to be a 5-day summer school at IIT Bombay campus, again majorly supported by DST, with maximum 25 participants, has now successfully transitioned into an online e-school with more than 1,000 participants. We organized our first e-school last year in 2020 in middle of the pandemic, and it received an overwhelmingly positive response. We hope that's how it will be this year as well. Okay, with this, to start today's inaugural session, I want to invite on board Professor Pradeep Kalbar, who, along with Professor Swatantra Pratap Singh, is the coordinator of eSchool 2021. Welcome on board, Professor Pradeep Kalbar.
thank you, Shiva, for nice introduction to the program. So I'll just give you overview of the uh, what we have been doing as part of this school. So uh, basically, welcome Dr. Akhilesh Gupta. So we have with us our eminent personality to inaugurate this summer school. Welcome to Professor Subimal Ghosh, who is a convener of the interdisciplinary program in climate studies right now. And so last year we had a very wonderful school, e-school, which had participants from 20 plus countries, and effectiveness of that school was rated by participants 9 on score of 10, and there were 11 faculty and 11 sessions where there it is 16 plus hours of learning. Right now it is around 5,000 views in YouTube, and we have also addressed many questions that emerging scientists and students have. And lecture themes were climate sciences, observations and modeling, mitigation and adaptation, climate policy, impact assessment, and vulnerability. And this is one of the sample feedback that we received from the students from University of Cambridge. So it was a big success, and the major
Sir,
feedback is written.
sir,
Yeah,
may I interrupt you, please?
yeah,
So the PPT is not on full screen.
not full screen. Okay,
No.
okay, it is because of maybe I have to.
This is a challenge, I also had. So you don't see it in the full screen. Doesn't matter, let it be, not in full screen, but let it
Yeah,
move.
now, right? Is it now, Shiva?
Yeah, yeah, yes, yes,
Yeah.
yes.
Okay. So yeah, we have this very nice feedback for the 2020 e-school, which is you can see very encouraging, and that's why we have this follow-up school this time. And this time we have the again very nice, very 1,000 plus registrations have happened, and these sessions will be recorded and will be available on YouTube channel, IDP Climate Studies YouTube channel. The link is provided in the brochure. So this time we are covering climate impacts, adaptation, mitigation, policy, climate vulnerability and assessment. And lecture topics are listed here, which will cover these broad three themes. As you can imagine, climate studies is a wide interdisciplinary research area, and hence we have tried to accommodate as much possible. And this kind of physical or online e-schools will keep happening, or even in other formats in terms of continuing education programs. We'll be delivering the knowledge that we're generating. And this time we have around 57% students, good around industry and NGO and government professionals are also joining this course. So we are disseminating this particular information as much as possible, and this is all possible with the generous funding that we have received through DST, through our phase 1 and phase 2 projects, which have been generating the knowledge, and we are disseminating through this e-schools. So with this, I hand over back to Shiva. Thank you, Shiva.
Thank you, sir. Now, I would like to invite on board Professor Subimal Ghosh, who is the convener of our interdisciplinary program in climate studies at IIT Bombay. Welcome, sir.
Thank you. Thanks, Shiva. I first of all, I warmly welcome you all to this eighth school on climate science and policy. Today, we are really fortunate to have Dr. Akhilesh Gupta from Department of Science and Technology to be among us. And thank you very much, sir, for accepting our invitation and to be present here. I know all of you are eagerly waiting to hear Dr. Akhilesh Gupta, but before that, I'll just give a brief overview about IDP climate study. What is it, and in what way it started? All of us are actually aware of the importance of climate change, specifically with the release of the sixth assessment report of IPCC Working Group One, where and as you all know that it has been considered as sort of a red code for humanity, which has given a very alarming notice and that demands for development of new science, new technology for understanding climate science, for better climate adaptation, and for better mitigation. And all of us are looking forward to seeing the working group 2 and working group 3 report in understanding that what are the possible adaptation and mitigations. One of the very interesting part of our IIT Bombay program of climate studies is that this is something which covers all the three areas of climate science: the climate science, climate adaptation, and climate mitigation. I'll just keep quickly giving a short overview of it. I'll just quickly share my screen. And yes, I hope so. The interdisciplinary program in climate studies was set up in January 2012 with the support, with the main support, with the key support from Department of Science and Technology, and specifically the support and encouragement from Dr. Akhilesh Gupta, who was the key behind this kind of program. And this is the first doctoral program of this country which is specifically focused on climate change, covering all the three areas of climate science, climate adaptation, and climate mitigation. And this is an interdisciplinary program. So climate science is an interdisciplinary program. Climate doesn't mean just atmospheric and oceanic sciences. It is an interdisciplinary program that covers multiple areas, and we consider it very seriously. And considering the interdisciplinary nature of climate studies, what we considered is that we have created an umbrella from under which we have 32 faculty members from 11 different departments across IIT Bombay. And we always make sure, this is a PhD program, we always make sure a PhD student is being supervised by faculty members of two different departments, so that the interdisciplinary nature of the PhD thesis is maintained. And you can see that the way we have made a huge growth in the number of students, of course thanks to the support from Department of Science and Technology, which has made it possible. And we have made a tremendous growth in terms of students intake, as well as in terms of increasing the participating faculty members. In fact, now we are going for recruiting the core faculty members. We have already recruited one, and we are expecting him to join next year. We are also thinking of recruiting different positions like visiting positions, professor of practice, etc. Now, in the research front, we have made a significant contributions. As you can see that over 8 years, we have published more than 135 international journal publications, and that includes journals like Nature Climate Change, Science Advances, Nature Sustainability, Geophysical Research Letters, Environmental Research Letters, Science of Total Environments, etc. So we have not only published good papers, but also we have hit some of the topmost journals in the world. And of course, our major research initiatives or major research activities is actually supported by Department of Science and Technology, so which was initially supported by the phase 1, 2012 to 2018, and this is further supported by phase 2, which is sorry, this years are slightly wrong. So this is 2018 to 2023. And here, what we are in the first phase, it was a seed grant where we are trying to understand different components of climate science, adaptation, and mitigation. But phase 2, we are actually trying something very exciting things, like we are trying to understand that how science and impacts are related, or science and adaptation are related. Let's say if we have an adaptation policy, what will be its feedback to the climate science? So in these ways, we are trying to connect all of them and coming up with holistic approaches. And also we are focusing on developing newer technologies towards climate adaptation and probably in climate mitigation as well. So these are the targets which are making us different from the many other different initiatives. At the same time, we have also parallel programs which is supported by NCAP, where we are focusing on black carbon, and Professor Chandra Venkatraman, who was the founding convener of climate studies, is actually leading this activity, which is also an important contribution at national level. And we have been, as you can see, that our faculty members have been, have been receiving quite a number of awards in both at international level and at a national level. And I'm really thankful to all my faculty colleagues for their excellent contribution to interdisciplinary program in climate studies. Our our students are also doing great. Like our students are getting international and national awards. They are getting the best thesis award in IIT Bombay, and they are also performing quite well. So this is a very, young center, a very new center. Like it has the age of only 8 years, but within that time also it has made a significant contribution in IIT Bombay at a national level as well as the international level, and we are really proud of our students. So thank you. These are a short introduction to climate studies. I once again welcome you all for joining the eSchool, and I'm sure that you will have an excellent, you will have a nice experience of of different areas and of different discussions related to climate science, climate adaptation, and climate mitigation. Thank you, everyone.
Thank you, sir. Thank you, Professor Ghosh. Thank you very much. Now, I would like to invite on board Professor Shubhankar Karmakar, who will formally introduce and welcome Dr. Akhilesh Gupta, and then we'll start his talk. Yes. Professor Karmakar, welcome. Welcome, sir.
Thank you, Shiva. So good evening, everyone. It's always been a pleasure, like to be a part of such outreach activities, like be it eSchool or summer school or QIP lecture sessions. So this year's eSchool is special, as we have with us as chief guest our mentor, Dr. Akhilesh Gupta, who has been a guiding light to our IDPCS since its inception in 2012. With this, with his constant support and guidance, IDPCS is being able to continue reaching greater heights. Before I invite him on board, I formally introduce him. Dr. Akhilesh Gupta, with a master's in physics from Lucknow University and PhD in atmospheric sciences from the IIT Delhi, is the senior advisor in DST, heading policy coordination and program management division. Prior to this, he served as head of climate change program of DST for last 11 years, coordinating two national missions on climate change under National Action Plan on Climate Change. He has also worked in India Meteorological Department, National Center for Medium Range Weather Forecasting and Disaster Management Cell of DST during 1985 to 2007 in various capacities, and was the secretary of secretary to University Grant Commission (UGC) during 2012-2013. Dr. Gupta was a member of National Coordination Team which drafted India's National Action Plan on Climate Change in 2008 and is main architect of India's new Science, Technology and Innovation Policy 2021, which will be released shortly. Dr. Gupta has received many prestigious awards. He is a fellow of Indian National Academy of Engineering and fellow of Indian Meteorological Society. Dr. Gupta had received appreciation of Honorable President of India in 2003 for providing accurate weather forecasting for the Mount Everest. He has published over 200 research papers in various national and international journals and proceedings of conferences. He is the editor of 5 books, authored over 350 articles and nearly 1,000 reports. It's my honor and privilege to be inviting him on board in today's eSchool inaugural session. Welcome, Dr. Gupta.
Thank you, Shubhankar, and good evening, all the panelists here and the distinguished participants joining from different parts of the country. It is indeed a privilege for me to be part of this eSchool on climate science and policy. I must compliment IDP for taking this forward for last so many years, and this has been very, very successful and become very popular among, especially among students who would like to, listen to these lectures and understand the climate change science and the other areas. Uh, well, I would like to cover. I think the Subimal has rightly pointed out that the working group one report or six IPCC is making a big alarming note to all of us. And this, I think, India must respond to all these red flags that have been hoisted. Let me mention here that, uh, right on the first assessment report of IPCC that came in 1990 to now, India has been, or rather, Indian research community has been responding to the international climate challenges. For example, when 1990 first assessment report came, although we didn't have any formal setup for climate research in the country, we did take up several initiatives like the India's methane campaign was launched in 1991 after that report when India was challenged about the methane emission that comes out from paddy field and also from the cattle. So India did prove scientists, our scientists did prove that we had the scientific capacity to respond to international challenges. After the second assessment report of 1996, we launched the Indian Climate Research Program, DST, launched in 1997. And there were several experiments. The LASCEX was launched in 1997. The INDOX was launched in 1999. The WONGX was launched in 1999, and so on. So those were the responses from India. The third assessment report, which created a lot of flutter in the in terms of the glaciology research that was included as a part of that. In fact, several new experiments were conducted thereafter. The RMX came in 2001. The TOGA, the TOGA 1 was launched with that is monsoon variability experiment in 2002. And then we initiated a International Center for Climate Research, which was later on positioned in IITM in 2002. That was the initiation of course, in this center came in 2010 later on. The real, turning point in India's response to the international call came in 2007 when the fourth assessment report came. India launched a national action plan thereafter and 8 national missions. 2 of the national missions came to DST for implementation. That is National Mission on for sustaining the Himalayan ecosystem and the National Mission for Strategic Knowledge Climate Change. We initiated, and this was the first time a coordinated research programs were launched by India beyond intramural. So far, they were mostly intramural, but this came as extramural research program and huge. As of now, will last about a decade. We have 15 center of excellence. We have 23 major R&D program, 14 network program, 7 human capacity building program, 8 global technology watch groups, 6 task forces, 25 state centers, and so on. So it's a It's a total program. 250 institutions were involved. Nearly 1,400 scientists and students were involved, and something like 2,000 plus research paper came out of these in last 7 years or so. 50,000 people were trained as a part of that. More than 1.5 lakh people were given exposure as part of these two missions. So, so much has taken place in last 1 decade because of the National Action Plan that was launched in 2008. Then came the fifth assessment report of 2014, and then the global framework came around the same time on climate services. And this also we had several new programs launched in this thing. Now 2021 and 22. 21 today it has come, the working group 1 report has come. Now in next year we will have working group 2 and 3 reports. These are going to be again responded to by the country. And how you will respond, this is what I am going to somewhat outline in my today's talk. Now let me just put it like, India, how it has worked in recent years in terms of what kind of uh, adaptation and mitigation action that have been taken. So, as I mentioned, so much has been done in terms of research program. But let me give you some figure that, as for the symptomatic study that has been carried out, it is found that India's output in research, climate research, got doubled in last 7 years. And, we in fact, uh, our rank, global rank also has improved from 15 in 2000, say 10 to now ninth. So there is a substantive increase in the research output because of the DST and other initiatives that came from. In fact, India's ranking in Himalayan research has improved substantially. In fact, now we are number 1 in the world, and nearly 63% of the Himalayan research comes from Indian authors, and nearly 50% of that has been contributed by DST alone. So that has, in fact, overall research contribution, global percentage or research contribution from India has also got doubled. So it starts only 2% in the year 2010. Now it is 3.5% of the worldwide global research in the period of 1 decade. See, India, in fact, number of publications in the climate research also gone double in last 6-7 years, and the this recent data shows that there has been nearly 2.5 times, 220 times increase in the number of research papers. And the DST fortunately has the largest share in climate research, among all funding agency. That's a big conclusion that is in. And much of these things came from this Center of Excellence. And IIT Bombay contribution has been very significant in this area. And so with so many of research scholars and students and the faculty working together, I think IIT Bombay was one of the best Center of Excellence of DST in recent time. Now, in the terms of mitigation also, India did very well. We had, in fact, our emission intensity, we promised that it will decrease by 20 to 25% of GDP by 2020 and 30 to 35% by 2030. And we already have, of 2005 level, we already have decreased the emission intensity by 21% between 2005 and 14. And this is, in fact, we are going to do much better than what we have promised. Similarly, we targeted that, the we will have 40% of the cumulative electric power installed capacity from non-fossil fuel waste energy resources. And this we have already in fact achieved 38% today. Energy is produced through renewable, and so this is a good achievement for India. India, in fact, today has become the fourth largest wind power generator. We generate something like 39 gigawatt of energy from the wind alone. Now, for the solar, we did something very, very outstanding. We, in fact, targeted to install 20 gigawatt of energy, solar energy by 2022. And this was our target. We, in fact, already achieved this target by 2018. And now we are targeting 175 gigawatt of energy by 2022 and 450 gigawatt by 2030. So therefore, India, so why I am mentioning this is the reason. So I am trying to bring a very important aspect after some time. You will see why I am mentioning this action by India. So what is important is that these mitigation action by India is actually, as per the climate tracker of UNFCCC, conforms to less than 2 degrees centigrade temperature rise by end of the century. India is one of the 6 countries which conforms to this less than 2 degrees centigrade temperature rise by end of the century through its mitigation action. That is very, very noteworthy and important. Now, when this 6 IPCC report 1, that is Working Group Report 1 came, on physical science basis, it's a major takeaway of this report is that, first of all, as Vimal mentioned, this gives some of the starkest warning about the deepening of climate emergency. With some of the changes that are, already set in motion through some irreversible processes for centuries to come. This is important for us to understand that we are inching towards an irreversible, situation. So, average over the last 20 years, the global temperature, over the next 20 years, the average temperature is going to rise by 1.5 degrees centigrade. Remember that as on date itself, the temperature from the uh, time of non-industrial time to now has risen by 1.1 degrees centigrade. Next 2 decades, we are likely to witness a zero point 0.4 degrees centigrade more temperature rise in globally, and regional anomalies will be much larger. Now, limiting the temperature close to 1.5 degrees centigrade or 2 degrees centigrade will be beyond our reach. If we continue to, do like the way we are working. Now, this is what is the alarm that now time has come for to use all kind of means and action to contain the temperature rise. So 1.5 degrees Celsius threshold is a crucial target because beyond this, you will reach a tipping point where the process becomes irreversible. That is what is worrying entire world. Uh, with 2 degrees centigrade temperature, we will have all extreme events dominating the atmosphere. So heat waves, heavy rainfall, the kind of other extreme, they will all, and then also the impact, the tolerance of humans and the tolerance of sectors like agriculture, health will be, you can say it will surpass that thing. So the more intense rainfall and intense of intensity of extreme events, they will put a lot of pressure on entire humanity. But let me put it in a, and similarly, one area which is again unnoticed by us and it's going to become very important is the sea level rise. The kind of changes that India has witnessed, Indian Ocean have witnessed in last 2 or 3 decades has been much more than what it had in the previous decade. India is going to witness this rapid increase in sea level, but also a rapid increase in temperature over Arabian Sea. Already temperature over Arabian Sea appears to have increased, and the number of cyclones over the Arabian Sea is showing increase. Also linked with this is the ocean acidification because large when you have huge CO2 content in the atmosphere that gets absorbed in the ocean, and so ocean acidification. Ocean acidification will lead to the impact on coral reef, and so all these are so linked with it. And then India has two major challenges. India has high poverty and high population density. So the implication of these changes over India is going to be insurmountable. So therefore, implication is that we will have, uh, enhance. We need to enhance our adaptive capacity. We already have very low adaptive capacity of these extreme. We need to enhance. How do we enhance? We need to have increase in the human development index. We are currently at 0.65. We need to become, you know, uh, worthy enough or stronger enough to withstand these high, strong, extreme events. The second very important inquiry is going to be on weather forecasters and disaster managers. It will become very difficult because the events become very frequent and severe. So they will have big challenge to predict these events accurately. And so the then the link with this issue is the warning system. So we need to have upscale our warning system. Now another important thing, India has most of the warning system is for individual disaster. You have warning system for cyclone, you have warning system for heat wave, you have warning system for thunderstorm and so on. But now in fact they're going to be multi-hazards together. See the example of, say, the Kedarnath event of 2013, showing that you have Glock, you had cloud burst, you had landslide, you have floods, you have so there were four different disasters were at the same time. Now, if you look at the issue, the cloud burst is being predicted by IND. Clock is handled by a department called GSI. Landslide is done by somebody else. The flood is done by the CWC. Different agencies are predicting different hazard. This is the big challenge. We need to have multi-hazard warning system in the country to address these issues. Then there. So in fact, India is now had to work on the challenges for climate research in the country. So there are five big challenges that, in my opinion, are going to be the research challenge of the country in next 5 to 8 years to come. First is the challenge on glaciology research. We need to upscale glaciology research for the Himalayan region. Climate modeling is going to be the biggest, task for the people, for the researcher. We need an Earth system model, or it should be a community model. We already have one Earth system model and run by IITM, They have an atmospheric ocean coupled model, which which include some components, all the system model like biogeochemistry and interactive CIs, aerosol, chemistry, transfer, etc. be included. And so it is a uh, model which is an ocean atmosphere model converted into a climate model. We need another model as a part of the community model system in the country. This is the second thing that is important. Urban climate is going to be very important. Urban climate is different from the global climate. The heat island can have severity as much as 6 to 8 degrees centigrade, as compared to 2 degrees centigrade global or 1 degree centigrade global. So therefore, heat islands are going to be very important. And the uh, big cities are going to have these impacts. Similarly, urban hydrology is different from the large scale hydrology. The cities are already experiencing heavy rainfall, extreme rainfall. We need a different research program for them. DST has already launched a national network program on urban climate. We need to upscale this to several cities. Right now, only 3 cities we have chosen. Also, the land use, land cover is going to be impacted very badly, and they will impact the climate and the hydrology. Therefore, the interaction of climate, the hydrology, and the land use, land cover for the cities become very, very important. This need to be taken. Extreme events are important. I already mentioned they need to be separately treated, not just part of a regular research program. Aerosols are going to be very important. They are already impacting cities. You can look at the how aerosols are impacting the Himalaya, how aerosols are impacting the rainfall pattern, because aerosol contribute as condensation nuclei, so rainfall intensity might increase. In fact, already there are studies showing that cities are showing increase, extreme rainfall. Why? Because aerosol contributions on the city is very high, and also the urban climate component is also adding to that heavy rainfall event of the. So these 5 areas are the research areas that need to be taken up. There are related areas like, how do we do it? Research funds need to be increased, and how do we get more funds? How the number of researchers need to be included, especially the young, researcher like students. How they get opportunity to get into the jobs? What kind of job requirements are there, and how we increase that opportunity? How the doctoral, postdoctoral numbers have to be. India produces 25,000 PhD every year. The PhD in weather and climate sciences is only 300 or 400 per year. How do we increase this number to 1,000? And how do we create more postdoctoral opportunities? There are very less opportunities for postdoc. I think I would just take another 2 minutes, 3 minutes, saying that we are in a very challenging time. I think we need to take up some grand challenges for climate research in the country. Time has gone when we were doing incremental research. Now we need to go for profound research. Large program which make impact. We need impactful research in the country, and not just delta research where we will make minor impact. Also, we need to create a system where intramural and extramural research are getting integrated. I think ministries and departments must join hands and create a national vision for climate research in the country. We need to strengthen the interministerial and interagency collaboration. I will give you example. The aerosols are being handled by 9 departments in the country. Glaciology is being handled by 7 departments in the country. I think this kind of uh, thing cannot continue. We need a close collaboration, interagency, interministerial working. Let's work together to deliver for the nation. So we need nationally coordinated, collaborative program and not individual based or individual, institution-based program. I think I have taken nearly 25 minutes or 20 minutes. So thank you very much. I think this is what I wanted to say.
Thank you, sir. Thank you, Dr. Gupta. It was a very insightful talk, really. Actually, we all lost connection in between at IIT, but yeah, everyone is back now, and thankfully, nothing went wrong with the talk. So I'm very thankful for that. So yeah, sir, we have few questions from the viewers. Kritika, can you start displaying them, please, for Dr. Gupta to answer? Thank you.
Okay, so the question is, what are the prospects for students who are planning to pursue environmental policy? Environmental policy. So, I think let me answer because I am also having another cap on my head that, I am the head of the policy research in DST. And we are, in fact, we have decided that every year we will have, minimum a dozen policy research fellow with us to work with this. So this time we have recruited 14 of them. Last year we recruited 18 of them. So these policy research fellows will be there for 2 years, and they are in different areas. And currently I have 3 policy fellows working in the environmental area also, and one is working on environmental engineering only. And out of these 14, there are 2 of them are in the environmental area. So I think they are good, and there are 10 Center for Policy Research in the country. IIT Bombay also has one, but there are many others. And so all these policy research centers are going to receive supports on DST now. We are going to start a Pan India policy research program where every policy research center in the country will become our extended goings of DST. So I think there are so much of opportunity that are coming up in the next few years.
I think the next
Yes,
question
sir.
is what can
Yes. Yes,
undergraduate
sir. The
students
next
do in
question.
fighting climate change?
Kritika, can you show that question again, the earlier one? Thank you.
What can an undergraduate student do in fighting climate change? See, this is, I think climate change is something which I think everybody can contribute. Whether you are a student or whether you are a researcher or whether you are a common man, everybody can contribute to climate change. And by doing very small things. If you are little conscious about the saving energy, saving water, saving food, they all are actually, they contribute to the climate change. And so if you are a student, just be mindful of what you are doing. See, when you go to your mess for food, people do a lot of, wastage of food, water, energy, all these contribute. So, energy saved is energy produced. Food saved is food produced. Water saved is water produced. Everything has, sustainability issue. So everybody and anybody can contribute to this thing. You just contribute to sustainability and you will be okay. I think you don't have big contribution. Even this much contribution should be okay with. So this is a very interesting question, carbon capture technology. It's like, I mean, when time comes for any, uh, climate emergency, where all mitigation action become, uh, I would say, not effective, then we need some kind of very different technology. See, so carbon capture technology is like you capture the carbon from the atmosphere and store it. Now storage can be two types. You can store it in the ocean, you can store it underground. But these technology have not proved to be very kind of, I would say, from the security point of view, they are not found very safe because they can explode later on, and they can this kind of capture may not be of very long-term, use. So now new technologies are coming up, and we are also doing research in this area. We are supported called carbon capture and utilization. Instead of storage, you utilize it. So carbon is captured and then utilized for some purpose. For example, carbon, there is in Tuticorin we have a small plant. The carbon is captured and converted into caustic soda, and that caustic soda is used for the industrial purpose and then recycled. So such kind of technology is being used. Now there is another carbon capture which is like, you take away carbon and then convert into some other useful material, like, take it, make it some kind of calcium carbonate in the conversion or something like that. But all these things that they're all at the research level. At the industrial scale, these have not been uh, tried, in a big way. But India has the capability to undertake such kind of industrial scale production also. But research level, we have, in fact, another capture is the algae capture. So you can capture it there are algae which can capture the carbon, and so these are the things that we have already funded some of these things. But as I said, this is the plight that India is having, that we are doing best in terms of mitigation. We are doing good in terms of research, but we are the worst impacted by climate change. So it is a very unfortunate situation, and there are people, there are countries in the world they do worst, but they are impacted the least. So this is the inequality that climate change has brought, and this is the one issue that we are fighting at the level of the climate negotiation level, that we should be paid for what we had done good, and we should also be paid for what we are going to suffer because of impact of climate change. After all, every citizen in the world has the same right, and that is the right for which we are fighting. Everybody has the same right, whether it is a man from Bangladesh or the man from US. Every citizen has the same right. This is to see this government policy is that we are not going to do away with coal technology. But what we are trying is that we should improve the, is uh, to make it more cleaner. So we are in fact focusing on clean coal technology, so that although in the energy mix we are targeting nearly 40% of renewable energy and remaining 60% as clean coal technology and other things. But we don't, India has rich resources of coal, and uh, if we make judicious use of coal through clean coal technology, I think we will not only contribute to the mitigation, but also with renewable as 40%, we will be able to have a very good energy mix, uh, 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 I would say, system in the country. So our policy is not, we are not going to do away with the coal technology, but make it more clean so that it contributes less to the emission. Next question.
Yes, sir. Yes, sir. Just we have actually many questions coming up, so just last two questions. Yeah. Yes, sir. This is the one.
So, can any adaptation policy be successful without integration of humanity, social science, adaptation more of private goods and localized? Now, why DST is not integrating? I think if you look at the some of the programs of DST, we are including society. For example, all state centers that all 25 state centers that we have opened, they all are actually working for the society. So not only just in terms of communicating to society in terms of public awareness, but also feedback from them to our research system. Also, the task forces for the Himalaya which we set up, they all are integrating this societal and to the society. So a large number of civil society organizations are part of these initiative of DST. One program I did not mention, I wanted to mention that we started a consortium on glaciology. That consortium was actually aiming to get the societal feedback on impact of glaciers melting on society. Similarly, I did a report. If you read, there is a report on DST website and also on Niti Aayog report. I was a chief editor of that report on Himalayan springs. So there are, large number of springs in the Himalayan region, and every spring in the country, in fact, all the nearly 50% are in fact dried up. So nearly you can say 30 lakh springs are there, nearly 50% dried out. Those springs are maintained and renewed by, regenerated by the community, not by government. So I think society has so much to contribute to climate change initiative, especially adaptation, because it is society which is going to withstand the climate impact. And therefore, they are the best to find ways and means to adopt this. So, so I think it's not correct that DST is not integrating social science. We, not every program will do it. See, there have to be some research program, but the good number of research programs are actually integrating society.
Yes, sir. Thank you,
Done.
sir. Actually, sir, we have 12, 15 more questions, which is it's difficult to cater to them right now for lack of time. So thank you very much, Dr. Gupta. I would like Professor Swatantra Pratap Singh to give a vote of thanks. So please.
Thank you, Siva. Thank you for inviting me, and good evening, everyone. So, just I will not take much time. On the behalf of IIT Bombay and IDP Climate Studies, we express our heartfelt thanks to Dr. Gupta, who is a scientist H and senior advisor in Policy Coordination and Program Management Division (DST), for his presence and providing an insight on the how the India Climate Studies program is growing and what kind of effort has been taken by the DST, and for his motivational word towards how we can change this effect, how we can reduce the overall temperature increase. We also are thankful to him and also DST for constant support to our IDP Climate Studies IIT Bombay. And again, we also thank our IDP CS convener, Professor Surmal Ghosh, and Environmental Science Engineering Head, Professor Subhankar Karmarkar, which is also a very important part of our IDP climate studies, for their presence and kind word. Along with that, we also thank Siva and the TAs for their effort, how they are till now they have managed the event. At present, we have approximately 1,000 registered participants for this 10 days eSchool on climate science and policy. We thankful to participant and hoping for a wonderful next 9 lecture based on climate science and policies by our 9 speakers. All speakers are expert in their respective area, and we are thankful to them for agreeing to deliver the lecture in this eSchool. So finally, once again, we thank Dr. Gupta for his presence on this inaugural function, and thank you all for participating in this. Thank you.
Thank you. Thank you so much. Thank you,
Thank you,
everybody.
sir.
Thanks for
Thank you so
inviting
much.
me.
Thank
I
you.
enjoyed this.
Thank you.
Thank you.
So, Siva, you can give just a brief about the lectures, what we are going to cover tomorrow.